Hello there. Welcome to week 5, where we're going to talk about exception handling and modular programming. Now, modular programming sounds like a very scary term, but in reality, what we're really just talking about is the fact that, up to this point, most of the programs we've been writing have just been jammed into a single file. We just have been compiling one thing, running one thing. And the issue with this is that, in real life, if you're working with programs that are, hundreds, thousands, or maybe even millions of lines of code, it's really just not feasible to have all of your code in one single file. So in C++, just like I would say almost every, if not every other programming language, you have the ability to split up the things that your code is doing into different files. And so the idea of modular programming is just about being able to split up the functionality of what is going on into separate modules, components of your code. So if some of your code has to do some math, maybe you should put all the math part of your program into one file and leave the rest of it, getting user input or that sort of thing, elsewhere. Exception handling we'll talk about too. So this is, sometimes your program can have something that shouldn't happen. You need to figure out what to do about that. So we're going to talk about both of these things today. Or I guess we're going to go through some examples of working with these things today. I'll talk about them in more detail in the lecture, and also. The course notes are, as always, here for your reference. But let's do some exercises. So create some functions that have 2 integer parameters, return the result of a mathematical operation, throw an error for an invalid operation. Consider what you can't do in math. Well, it's a really obvious thing that you can't do in math. I'll give you a second to think about it. And if you aren't sure, probably remind double check your calculus, because this is a thing that you have to check for all the time. And of course it is dividing by 0. You should never divide by 0. The trick though is that C++ will let you divide by 0, and I can show you right here. If I make a little notebook here and ask what's 5 over 0. No, actually, yeah, so it warns me. It doesn't give me an error. It says, are you sure you want to do this? But it actually does the computation. 0, of course, being very much the wrong answer. But, it'll do it. However, if you're writing a program that does some math, you probably don't want to just have a warning that says, oh, maybe don't divide by 0, and then it just, go ahead and do it anyway, because this might give people the impression that something over 0 is 0, and that's probably not true. So we need to figure out, how to deal with these kinds of things, and that's what we're going to be working on today. But first, some functions. So we need to, let's grab our description of what we have to do here. I guess I'll leave that, that's fine. Okay, create functions with 2 integer parameters, return the result of a mathematical operation, and throw an error for an invalid operation. So there's a lot of different ways that you can deal with errors. One of them is throwing an error. So you essentially are just telling the computer, hey, something that should not happen is happening, and so we're going to throw an error when that occurs. So let's make some functions. I guess we have to do each one. So int, so these are integer parameters, so they should all be integer results. The division, you could argue maybe should be a double, but we'll, actually, yeah, sure, why don't make it a double, that's fine. Okay, so there's add, of course. We got integer number 1, integer number 2, and just return number 1 plus number 2. Subtract, multiply, and then here's the one where I have to worry about things. So for divide, we don't want to just do this. We'll leave it as integer, I think it's fine. If you really want to make it precise and use doubles, you can do that. But here is the thing. If num2 is 0, now we have a problem because we're going to attempt to divide by 0. So rather than just doing that, what we will do is we will throw an exception. And we'll throw divide by 0 error. I may have the syntax messed up for this, but we're going to find out real quick. Seems like it's okay. So if I divide 10 by 5, gives me 2. And if I divide 10 by 0, I get an error, but I think I have this formatted incorrectly. So this is a case where I'm going to go and reference some notes so that we can make sure that we're throwing these errors in the right way, because I think this is the wrong way to do it. Obviously, an error has occurred, so I got something going on here. But I think the issue is that when I throw my error, just giving it a string is not really going to do what you're looking for. So let's check out our notes, and we can make sure that we have some good references for how this should work. Yeah, C++.com, excellent website for stuff. So now here is I wasn't sure actually if it would let me throw an error and then not have some blocks to handle it, but it looks like I do have to handle the error. I can't just throw one. So anytime that an error is thrown, so you use the keyword throw and you have some value after it, what happens is the computer says, oh crap, I have to stop. I terminate the program and I don't go any further. So you can see here we hit an error, we're done now. Presumably I can still do this, yeah, and so there's an error because I'm dividing by 0. Now here's the issue. I want to print out divide by 0 error, but I have nothing to actually tell it to print out divide by 0 error. So, what do I do here? And the answer is anytime that you have some code that is vulnerable, is potentially going to lead to errors. So presumably you have the word throw somewhere. You want to surround this with a try catch block. Now, this is just like an if statement block, like an if else kind of. And what it is the word try indicates, attempt to do this. And if an error is thrown in the middle, don't crash the program. Instead, do a thing. So what we'll do is we're going to surround, we could surround the line of code, which I guess is fine. You also could surround the if statement. It doesn't matter too much, but we're going to try. Actually, yeah, we'll try all of this. Why not? So we're gonna try all of this. I should disable notifications so that the sounds aren't bothering my video. It's okay. So I'm gonna try to do all this, and I'm going to catch a string s. And so what I'm looking for is, you can think of this as, if you're playing like a sport or something, what happens when somebody throws an object while someone else tries to catch it. So the idea here is you try to do some stuff. If an exception is thrown, you need to write part of your code that will catch it and then do something with it. If it's thrown and there's nothing to catch it, then you have a problem. So here we're going to catch the string and we're just going to output the string. Okay, so boom. Oh yes, I should save this. So this is example 1. Okay, why are you angry? Oh yes, I forgot our good friend namespace. Include iostream using namespace. Oh, I forgot to return. I guess so. In this case, if I have an error, I do want to return something still. So in this case, what we'll do is we'll return. Not really a good answer for what should be returned here. We'll return -1, but probably should figure out a better way to deal with this. Anyway, okay. So now it's there. So when I divide, normally it's fine. But when I divide by 0, it still doesn't work. That's always fun. Okay, well let's make sure that this is actually catching it. So let me check my example here. Actually, let's see if this works in, my last pass expired, well that's sad. Let's see if this works in C++. Could be the notebook is doing weird things, as it tends to do. So let's make a new file, example1.cpp, and we'll see if this is just a case of the notebook doing silly things, or if it really is, I made an error somewhere. You never know, could be either one. So here is our code that we have to have. We'll make a little main function down here, and we're going to try to division a result, and then we'll output divide 10 by 0. I guess we can do it twice, and one time we'll do it 10 divided by 5 so we see it work properly, and then one time where it will not work properly. Sure, why not? All right, let's run this, see what happens. Example 1, go. Woof. Okay, so an error has occurred. Terminate called after throwing an instance of. So what it sounds like has happened here is it didn't actually catch my error, because otherwise it should have printed out the thing. Instead it just says we threw an instance of char const star, and I think what may have happened here is that it's not actually recognizing the string. Maybe if I include string we'll do this. I'm not quite sure. I can try. No. Okay. So, let's try something else. Let's make a string error message, which is this, and we'll throw the error message. Missed a semicolon. Boop. Haha, okay. And perhaps that is the problem with our notebook as well. So let's go check out our notebook. I think what's happening here is that C++ defaults to not recognizing that this is a string and assuming that this here is a character array, which, you know, usually is the same thing. But in this case, because I'm not making a string variable and I'm instead just putting some text, the default assumption is this is a character array. So instead we're going to do exactly what we did over here. We're going to make an error message and throw that. And that way it will be caught by our exception thing down below. And look at that. We got what we wanted. So, I think that's our first little exercise. We throw an error, and it is caught over here. Now, notably, if I threw this error and I didn't have it inside of a try-catch pair of blocks, the program would just crash, like we saw before. When I don't have try and catch, if you throw an error, you're just telling the program, terminate, stop. Clearly something has gone wrong. If you want really good code, what you should have is any time that there's a potential for these kinds of errors, to make sure that that part is inside of a try catch so that you have something that you can do to handle the situation. Okay, well, so we've done our first little exercise. Let's try the second one. Modify your code by creating an operation class with 2 integer attributes, and its methods are the functions you wrote. Use try-catch statements to handle under or overflow in some stuff. So let's get this going. I think we can do this in our notebook as well. It should be fine, and I guess we'll find out. So let's make a new notebook though, and we'll call this one example 2. Example 2. Here's what we need. An operation class. Okay, so let's include our usual suspects. Do we need string? I don't think so. We do need this. And we're going to need a operation class. 2 integer attributes. It doesn't say if those have to be private or public. I'm going to be very lazy and make them public, because why not? Int number 1, int number 2, and its methods are the functions that we wrote before. So let's go back and grab those functions. So we got add, subtract. Now, actually, I think these are going to end up being a little more complicated than a single line. So maybe I shouldn't do these like this. And what I should do instead is actually just have the declarations here, and we'll do the definitions later. Subtract, multiply, and divide. Now, divide we've already got handled. I suppose, yeah, divide can't really go wrong other than dividing by 0, so this one is pretty straightforward. We can just take this one. This belongs to the operation class. Also, we should put this in a separate notebook block so we don't have too many functions in the same spots. Okay. So we got our divide because we already did that one from before. Now, overflow and underflow, these are things that can be very hard to track, and we're not going to be able to do it perfectly here, mostly because, well, actually, maybe we can try. We'll see what happens. So what do we mean by overflow or underflow? Well, when we add two numbers together, if they're integers, there's a limit to how big an integer can be. You can look that up. Max int size in C++ is this big number here. I'm going to steal this number. Now, my concern is that if I try to add numbers and go beyond this, something might not go quite right. What if I try it here, just for fun? I got a -2, so that's probably not great. And here you can see what happened. There's an overflow in the expression. So my issue is that there is a possibility that the numbers I'm adding together are simply too big if I'm using, for instance, add. So what I need to do is do a try catch, and then see is the number too big. So we'll start off by, since we're going to use this variable a bunch of times, let's actually put it inside here, which is going to be int max, which is a constant int. Max int. I'm putting it in all caps because this is going to be something that never changes, and it's this value. So that's as big as we get. Now, if I make an operation O, and I try to get O dot max int, gives me the big number, cool. And if I try this +1, it becomes a negative something very big. So that's probably an issue. So how do we deal with this? I think we can try a few things and we'll see what happens here. But the trick we have to worry about is that when we evaluate the result of the addition, if it overflows, then there's a lot of different possibilities of what could happen. So let's take, for example, suppose I took this number and I multiplied it by 3. So this is the wrong answer, right? It's like 2 lower than the other number. So some weird unpredictable things can happen depending on how much bigger we try to go over the integer that's there. So there's no real easy solution to figuring out the best way to identify that an overflow is going to happen, since this is a warning, not an error. So what we're going to do is we're going to cheat a little bit, and what we're going to do is we're going to take our addition over here, and what we're going to say is, you know what, neither number can be bigger than half of this, because if either number is bigger than half of this, we have the potential of going over the amount that we're wanting. And I guess technically, if we're just if the worst we can get is double, then it's always going to be negative, right? Although then it's also hard to say because we want to make sure we're not worrying about, what if I add negative this plus itself, right? Negative 2, 1, 4, 7, 4, 8, 3, 6, 4, 7. This turns into a 2. kind of weird stuff happening with these big numbers, right? So here's what we'll do. Here's our function. We're going to try and catch some stuff. So try. Well, I guess here's what we'll do. So if number 1 is greater than max, and this is in our operations class, max int over 2, or number 2 is bigger than that, then we just refuse to add them together. So we'll output too big, can't add these. Actually, no, this is where we'll throw our exception, right? We're going to throw, so sorry, not cout. We want a string error equals, I'm going to throw the error. I'm going to put all this inside of a try block. So try this. And we'll catch string s. And then we'll output s and return 0. So let's try this out. Hold up, what did I mess up? Missed a semicolon. Okay, so we'll try o.add o.maxint and 1. Too big, can't add these. Look at that, just as we expect, because this number is too big. What if I put divided by 2? Now it's fine. Add some numbers together. As some practice, I recommend do this for the other ones. Multiplication is kind of tricky because then you have to actually figure out the square root of this of maxint, which I guess you can grab from another source if you really want to. But really the point here that we're trying to get across is try and catch. Catch will take whatever type you are throwing and do what you need to do with it. In this case, you want to print out the message. There are a few other things you could consider. Maybe you want to have an error code number. So the example in C++, for instance, just throws the number 20 and then prints out, there is an error, it's error number 20, for instance. But you know, how you handle the errors really is a contextual thing and depends on what you're trying to do. Okay. So I'll just handle the one, and I think it's a good idea for you to try doing the other examples. Let's finish up with exercise 3. Yes, okay, so here we're dealing with multiple files, and here's where we're going to have to get, step away from our notebooks because this is something that is specific to working with CPP files. So my operation class needs to be in a header file, it needs to be imported into main, and then I need to run it there. So here's what we'll do. We're going to make our new we're going to make some files. So the first one is going to be operation.h, and this is the header file. So what this is going to contain is exclusively this information here and this. You can think of a header file as a summary. For anybody who wants to use your code but doesn't want to have to like read through all of the program that you've written. So the header here contains just the basics of what's necessary to understand what's going on. Ideally, you might want to add in, if these were less obvious methods, what they are doing. So somebody who's reading your header file can see, oh, this is what the program does. Then when they open operation.cpp, that's what the actual code is. So operation.cpp. And this is where you would have the actual code. So everything that's here goes in it for sure. I don't know, I didn't copy all of it, but that's okay. And here I need to put in my actual code. So here's my divide, here's my add, and if you wanted to do, you know, subtract and multiply, you can do those too. I'm just going to leave these as is for now with the signs changed, but obviously these are not quite what's there. Can't subtract these, can't multiply these. Obviously, you know, there is a potential for overflow here because this isn't quite right, but I'll leave it to you to fix that up. So, okay, this is done, this is done. So I now should be able to compile operation.cpp. And the only error I get is undefined reference to main. And so what's happened here is I don't have a main function. So when I try to compile, it's like, oh, but you can't execute this. But that's okay, because I don't want my operation class to do anything. It just needs to explain how it works. My code that actually does stuff is going to be in main.cpp. And this is where I actually use everything else. So for this, I'm going to include IOStream and use namespace Steve. I'm going to include one more thing. And the thing I'm actually going to include is operation.h. So now when I'm writing my main function, I actually have access to everything that's in my operation header file. All of these functions, I can now use them. And when the computer tries to figure out what they do, it goes to operation.cpp, provided I give the compiler instructions to compile both. So just to test this out, again, we'll grab our little snippet here. We'll try to do this, and we'll try to do this. We'll try to divide 50 by 0. That should give us another error. And we'll try to do a division that will actually work, just so we have some things. And we'll output these. Just so we can see what's happening. Let's put some messages in here. So this one is adding. First division. And second division. Okay, now I think if I compile main, it might mess up, but let's find out. Main.cpp. Okay, and so it immediately is like, what the heck, where is this add thing, where is this divide thing? It's very confused. So in order to compile both of these, what I'm going to do is I'm going to compile operation.cpp and main.cpp, and I'm going to send them to example 3, because that's what we've done. And now here, no errors. So what has happened is I've told the compiler you must compile operation.cpp because it has code in it that you need to figure out how it works. And you also need to compile main.cpp because that's where the actual main function is. When I execute example 3, there's only one main function among all of my code, and it's the main function right here. So when I execute it, it's going to execute from here, and it's going to know what operations are and these methods because it checks the includes and sees operation.h, which then says, here are all the things that you can do with operations. How do they work? They're inside operation.cpp. And now when I run this, /example3, I can't add things because they were too big. When I try to divide, I get divided by 0 error, but the second division works totally fine. Exactly as I expect. And that's it. So, in general, it is a good practice to have header files anytime you have more than one file going on. Generally, if you are using a class as part of any like lab test or real life code, that class probably should be in a file by itself. And it should have a header file that contains the declarations of everything that the class is going to do, but the actual code itself is all inside of the CPP file. So divide, add, and so on are all defined in here, what they do. But in our header file, we have what is the class, what are all the functions that it works with, what variables does it have. We even have an actual line of code in here that does something, which is assigns max int to this number. But ultimately, the header file should be devoid of any code other than statements that are necessary for someone who's reading this and wants to know what's going on. You can think of this kind of just as the, like, the Spark notes or equivalent of what the class is actually doing, because the real class is obviously going to be a lot longer. So as an exercise, definitely recommend seeing if you can figure out some ways that you can make better if statements than I have for catching underflow and overflow. In fact, there probably is an actual way to do it. I was just a little lazy today with that. But exceptions come in the form of generally throw, and you can try and catch. There are a few other ways that you can do things as well. So if you look through the notes, which I definitely recommend, you can see there's also classes that represent exceptions. And then one last thing that you can actually do as well is you can actually just have a catch that is designed to accept anything other than what the other catches have. So for example, Let's say, where's a good example? Maybe over here, if I try and I divide, and let's say that int num1 is greater than max int over 2, and for some reason I'm concerned that maybe this won't work, I can also throw something else. Let's say I throw a 0. And then 0 is obviously not going to match a string, but I can also do catch ... and output num1 is too big. And now here I can double check that this works by going back to my main, and we'll try another division. And our third division is going to try to divide with, what's the maximum integer? This one. Let's try it out. And there we go. Third division number 1 is too big. So what happened here is my, when I have this try block, you can see there's actually several different possibilities of where exceptions can be thrown. Here it throws a 0, here it throws an error message, and after the try block, I can have as many catch blocks as I want, and each one catches a different kind of exception. This one looks for a string, this one looks for anything that made it here, but I also could have something that catches a specific class. So you can imagine that if you want to throw a class that you have created yourself to represent some kind of exception, you can do that as well. Some instructions for this can be found in the notes, particularly on the second link here, on how to use classes for exceptions. It's a good idea to get some practice with this because handling exceptions is not something that is going to drastically affect how your code runs, but is the kind of thing that helps to make sure that your code is actually safe. So you don't have issues where someone can divide by 0 when they really shouldn't. And there's all kinds of stuff you can do with regards to figuring out how to handle these kinds of exceptions. That's pretty much it, I think, for this video. I don't want to keep it too long. You can always find the code here in videos under week 5, and we'll talk about more in our next video. So I'll see you then. Goodbye.